Hey friends, welcome back to your own channel. In this video, we are going to cover visualization using Python, continuing from our last video. If you are new to my channel, I would encourage you to watch the previous parts of this Learn Python series. Also, if you like the content that I post, please do subscribe the channel and please hit that like button. It's a small effort from your side, but it gives immense motivation to us. Please do that right away. Before we begin, I would like to give you a glimpse of today's session in a fast forward. There you go. Okay, so let's begin. So we are on the new Jupyter Notebook file, and let's begin by importing the libraries that we require. We require pandas to manipulate data frame. We require NumPy. We also require Matplotlib. And within Matplotlib, we require PyPlot. So we are importing PyPlot from Matplotlib as BRT. We also required Seaborn library. And I'm also passing argument Matplotlib inline to make the plot visible within the Python notebook. And let me execute this up. Now, if you don't know why these libraries are being used, you should watch previous video. I'll put link right here and also in the description box. So today's dataset I have is the same dataset which we used in our last video. That's an Excel file. So I'm calling pd.readExcel from pandas. And the name of my dataset is car insurance. It's basically an insurance dataset. I'm going to read this file and storing under the object data frame, df. And as it executes, let's see the top sample, maybe top 2 records from the data frame. And this is how our data set look like. We have total 21 columns in our data. And if you want to check the shape, we can do df.shape, and that will give us the number of rows. That's 7,647 across 21 columns. So that's the kind of data we have right now with us. Let's begin our today's session by calling our first plot of the day. That's linear model plot. That's nothing but lmplot. So lmplot is again a variation of scatter plot. It fits a linear model between two numerical variables, which we are going to see in a scatter plot, and it will also give us the best fit line. Let's see how we can call lmplot, how we can create lmplot. So we're going to call SNS library, and from SNS library, we're going to call lmplot, right? And we're passing our argument data, that's my data frame df. And on x-axis, I want to understand income. And on y-axis, I would like to understand the home value. I want to see the relationship between these two variables. And we execute this. Okay, let me execute this cell. As I do that, I can see the relationship between income and home value. And I can also see the linear model, which is fitted by Python, particularly Seaborn, on these two variables. And I can see there is a clear positive relationship between my income and home value. And with certain level of confidence, I can say that as my income increases, my home value also goes up. The blue line which you see on your graph, which is nothing but it's your linear model, which has been fitted on your data points. And the shaded light blue area, which is again a confidence interval. In case if we don't want that confidence interval, what we can do is just pass this argument ci, which is confidence interval, is equal to false. And as we execute this, this will give us the shaded blue area removed, and it just gives us the pure mortal line. Now, if I want to understand different populations and their relationship, particularly with respect to home value and income, I can do that. So let's just copy this particular code and paste it here. Now, I wanted to understand different populations within this two variable, maybe under different car type. So I can pass on this argument called hue, and hue is nothing but it's my car type. As I do that, Seaborn has created this complex chart for me. For each of the car type, it has created the correlation between income and home value by fitting linear model to it. Now, this chart is good, but it's very complicated to decipher any insights out of it. So it's better to create individual chart for individual car type. And we can do that with the help of lmplot only, but we need to pass argument in a different way. So let's try and do that. Let's call sns.lmplot again. And here I'm passing my data, which is nothing but df. My x variable is again income, and my y variable is again home value. Now here, I'm changing my hue. So I don't want to see the hue, but I want to see each car type in an individual graph. So I'm passing this argument called column. In column, I want to see car type. And I don't want to see the confidence interval. So I'm passing ci is equal to false again. And I also wanted to see individual graphs. So I need to pass this argument called column wrap. Column wrap is how many graphs you want to see in each of the row. So here I want to see 3 graphs in each row. That's why I'm passing 3. So I do that and execute my cell. The Seaborn is going to give me individual chart for each population. So I have 6 different population. It has created 6 different plot. Now the first chart that you see on your screen, which is nothing but its home value against income chart, but only for the population of SUVs, so only for SUV cars. Similarly, the next chart to it, which is only for panel truck, and I can see where the relationship is more stronger or where it is weaker or where there is no such relationship exist in each of the population, and I can decipher more insights out of it. So this is another attribute of lmplot. Okay, so next chart we have with us today is joint plot. Now joint plot again is a variation of scatter plot, but joint plot helps us to see 3 different charts on a single chart platform. It gives us the correlation between 2 numerical variables. Also, it gives us the distribution pattern of these 2 variables on its respective axis. Let me try and show you how we can create joint plot, and I can explain you more from there. So let's call joint plot from our SNS library. And here in this case, I wanted to pass on my data is equal to df. My x-axis I wanted to pass as a blue book value, which is the car value. I also wanted to pass my y value as income. And as I execute this, it gave me the scatter plot between blue book and income, but it also gave me on its respective axis the distribution of blue book on x-axis and the distribution of income on y-axis. With certain confidence, I can realize that where is the concentration of records across these 2 dimensions. And this is very powerful tool compared to normal scatter plot, where you cannot ascertain the density of your records at particular range. But with the help of joint plot, you can do that, right? Let's try and customize the joint plot more effectively. Now, instead of the point plot, if I wanted to have hex plot, I can do that. Let me copy my cell here and paste it here. Now, instead of having a point plot, which is by default, I can pass this argument called kind. And in kind, I can pass hex. That's going to give me hex plot, right? So instead of just point density, it's going to give me hex plot with a color encoded graph where the dark hexagons represent some more density of the records available in that particular range. And this is more effective compared to the normal joint plot which we have seen previously in some cases. Okay, if you want to see the KDE, like kernel density estimator, we can do that. And we can copy the cell and paste it here. And instead of kind is equal to hex, we can pass KDE, kernel density estimator. And we can also pass this argument called fill is equal to true to make it more visually appealing and color coded. And let me execute this cell. Now, if you don't know what is KDE, you must watch our previous video where I explained what is kernel density estimator in simple words, and you can learn from that. As you can see that we got the KDE chart and we got the distribution smoothened up and a curvature. KDE gives us the smoothened plot of distribution for both the variable. It also gives us the density of the records at particular range in a color encoded smoothened format. So this is KDE chart for you. If you wanted to see the regression plot in a similar joint plot format, we can do that. Let me copy this cell and paste it here. As I do that, instead of kind is equal to hex, we can pass kind is equal to reg. Reg is nothing but a short form of regression. So it's kind of fitting a regression model on a two variable. Let me execute this. As I do that, I can see the linear model has been fitted between the blue book and income. And I can also see the distribution along with the KDE line for both the variable. So the next plot we have with us today is violin plot. Now violin plot is extension of the box plot that we have seen in our last video. But violin plot offers a much more insights compared to normal box plot. It also gives us the distribution density in its body. And let me show you how we can generate insights out of the violin plot. So we can call from SNS library violin plot. And here it's called data is equal to df. And we call my x variable car age. So I wanted to see the car age distribution using violin plot. As we do that, we see that it looks something like box plot, but there are more insights out of this. The little white spot which you see on the graph, which is a median value of car age, and the shaded black area which you see on your screen, which is nothing but interquartile range. So it's essentially the middle 50th percentile values. So from 25th percentile to 75th percentile, that's your value. And that's IQR being displayed on violin plot. Now, the wider section on violin plot, which represents a higher probability, and the skinnier sections on the violin plot represent lower probability of a given value. And this is more intuitive when you compare this with a normal box plot where you don't find this kind of a distribution probability available. So you can use violin plot as in when you require to generate this kind of insights out of your dimensions. Now let's see how we can customize the violin plot further. If you wanted to study more population within violin plot, how we can do that. Let's call sns.violin plot. And here we're going to pass data is equal to df. And I wanted to see this violin in a vertical way, not the horizontal way. So I'm passing y argument here, and my y, I want to see the car age, and I want to see car age across all different car types. And I can pass this argument called orient if I wanted to see it vertically. As we execute this, it's going to give us this beautifully created violin plot for each of the different car types and giving distribution of car age in this individual population. As you can see that the minivan is having the highest median car age. This is a default color palette. In case if you want to have a different color based on your color theme, you can include the palette as an argument. Let me copy this and include palette as well. So you can pass this argument called palette. where it is. And as we execute this, it's going to give us this color, which is green violet. Moving ahead, the next plot we have in our session is strip plot. Now strip plot is again extension of scatter plot, but in strip plot you can see population of records across different categorical as well as numerical variables. So that kind of flexibility you have in strip plot when you compare it with scatter plot. Let's call this strip plot. So let's set up our figure size here. So we call plt.figure, and I wanted to see fig size is equal to maybe 15 by 7 plot. And let's call our strip plot using sns.strip plot. And I'm passing my data is equal to df. My x variable is occupation. So here, this is my categorical variable, and I wanted to see car age. This is my numerical variable, right? And as we execute this, it's going to give us this beautiful strip plot where I can see what is my average car age and the number of records available against that car age. I can understand more about the density or the distribution across that particular car age. Now I can see here that the blue collar and student have been using the car which is more younger, maybe less than 20 years old, while people who are lawyer or maybe a manager are using car as old as 25 years. So this kind of insights you can generate with the help of strip plot, and you can use two different categorical variable as well as two numerical variable, unlike what you do in your scatter plot, right? You can also use maybe hue to differentiate between other different populations. So let me just copy this and paste it here. We can pass hue argument with gender, and let me execute this. As we do that, the blue dots which you see, which are female, and orange dot which you see are representing males in the data. As we can see that homemaker by default and intuitively, they're more dominated by female. And similarly, you can see the orange dot in some cases. So those kind of insights you can generate with the help of hue, right? Let's see our next plot in today's session, and that's cat plot. Cat plot is more broader framework which provides access to different type of plots, including strip plot, song plot, box plot, and it supports around 8 different type of plot. So cat plot is more powerful. Within just one plot, you can create 8 different types of plot. So let me show you how we can create cat plot. Let's call SNS cat plot. And here you can pass data is equal to df. In my X, I wanted to pass M status, which is marital status. And on Y, I wanted to see the car value. Right, and as we do that, by default, it takes a strip plot. So it gives us the density of records and their blue book value across different marital status categories, right? Now, if you wanted to study maybe different type of plot using the cat plot, we can do that. Let me show you sns.cat plot. And here I can pass data is equal to df. On my x-axis, I wanted to pass maybe occupation. I also wanted to study y as car age, and I wanted to pass hue maybe as, let's say, gender. And I can pass this argument called kind. Now here is I can provide the type of chart that I want. So I want a line chart. So I'll say point plot. Give me point plot, and as I execute this, it's going to give me the nice plot, the little lines which you see on a point, which is nothing but confidence interval. Now if you don't want that, you can pass this argument called ci is equal to false, and it will remove those lines for you, just give you the point plot. The good thing about cat plot is you can create multiple populations. So it's not limited to maybe 2 or 3 variables. You can use multiple variables to create charts. So you can use as high as 4 or 5 variables to create graphs for you. Let me show you. Let's create box plot, right? So let's call cat plot again from SNS. And here I'm passing my data is equal to df, and here my x is occupation, and my y is car age. Now, I wanted to see hue is equal to maybe gender, and maybe my column I can pass as urbanicity, and I can pass kind is equal to box to create box plot, and I am also passing palette is pastel. Let me execute this. This is going to give you all different plots. Now you can see on the first plot, which is only for population which is highly urban or urban population. Now within that population, I can see the distribution between car age and occupation segregated between male and female. Now there are 4 variables, if you can see: urbanicity, car age, occupation, and gender. So you're using 4 variables to understand the very micro population amongst your data set. So this is very powerful way when you want it to go in exploratory mode and see your data through, right? You can change your palette and create more interesting chart. Maybe instead of pastel, you can use bright, and that will create more bright chart for you. So the next plot we have in our session today is pair plot. Now pair plot is nothing but it's a combination and group of scatter plot, and pair plot does is it takes each of your numerical variable and creates scatter plot for every possible pair between 2 numerical variables. Pair plot is more effective when you are creating model and you're understanding the correlation between different numerical variables, and it gives you kind of a visual representation of every possible pair of a numerical variable and correlation between them. So it's very powerful in that way. Let me show you how we can create them. So let's call sns.pairplot, and here for the simplicity I'm passing limited data rather than passing all numerical columns. I'm going to pass very selected columns, so maybe income, your car age, maybe blue book value, maybe home value, and maybe claim amount and claim frequency. Right? As we do that, it's gonna take some time to create, and it has created this graph. Now, how do you read this graph? On the y-axis, you see it's income, car age, blue book, home value, claim amount, claim frequency. On x-axis, you also find the similar attributes: income, car age, blue book, home value, claim amount, and claim frequency. So essentially the first plot which you see on your screen, which is nothing but it's income versus income. So diagonally, you see it's more of a histogram of that particular variable. But off the diagonal, you see it's a relationship between, let's say this chart, it's a car age and against income. This chart is blue book against income. This chart is home value against income. And you see diagonally opposite charts are similar charts. The second chart which you see here, it's car age versus income. The chart which you see here, which is nothing but income versus car age. So in essence, they are the same chart, only the x's have been swapped, right? So if you don't want to see this top triangle, you can pass this argument. Let me copy this code and paste it here. And you can pass this argument, corner is equal to true, right? As we do that, it's going to remove all the duplicate chart and provide you a unique chart of the diagonal, and you can study those charts. So it gives you the diagonal, that's histogram, and it gives you off the diagonal charts, which is unique chart. It has removed all the duplicate chart. You can also pass hue like other charts. Let's pass hue as gender, and here we wanted to pass it differently, so we can pass like this: data is equal to df, and we need to pass variables. So vars is equal to this particular list of columns, and maybe we can pass hue after that. As we execute this, this will give us the pair plot between the 6 different features, and it will also take hue into consideration. So for male and female, it gives us the separate scatter plot. It will differentiate using the different color codes. It has automatically created KD chart for us on the diagonal, which gives us the distribution between 2 different genders on this different variables. But off the diagonal, you can see the scatter plot again differentiated between different genders, just the way we seen it previously, right? So the next plot we have in today's session is very important, heat map. Now, heat map is a graphical representation of the data in color encoded matrix. And heat map is very useful, particularly when you want to understand the correlation between different variables, but it can be used for other purposes as well. So let's see how we can use heat map to create our chart. Let me create a new data frame. Let's call new DF, and here I'm taking a selected columns from my data frame, maybe the 6 columns. So let me copy this columns here. For the simplicity, you can try when you practice it to create using all columns. So let me create that. So my new data frame, if you want to see, looks something like this, where I have just 6 columns like this, right? Now, if I wanted to study the correlation between the 6 different columns, I can do that. And I can call simply new underscore df dot core, and that this will give me correlation between each possible pair of the 6 different features. So I have income, car, age, blue book, home value, claim amount, claim frequency. Similarly on x-axis I have the same, and this table gives me diagonally, you can see it's a correlation value of 1 because it's income versus income and car age versus car age and so on. So its correlation is 1. But off the diagonal, you see the correlation between car age and income is 0.39. If you don't know what is correlation, I'll put the link right here. You must go and watch the video of correlation to understand it fully. So here you see it's a positive correlation between car age and income. And similarly, if you see the diagonally opposites, it's again income versus car age. So you get the same correlation value. But it's a very dry figure table. If you wanted to see this table in a visually appealing way, you can use sns.heatmap. And we can call sns.heatmap. And within that map, we can pass this particular value table. As we do that, we're going to get this heat map generator. Now, this is a color encoded matrix. So you can see that wherever there is a color is very dark, the correlation is nearing to 0, or there is no linear correlation. But as the color is nearing to light, maybe peach, there is a high correlation which exists, right? But if you wanted to see the value of the correlation on this little boxes, we can do that. Let me copy this again and paste it here, right? And we can pass this argument called annote. Annote is nothing but annotation. So if you want to keep annotation there, we can pass this argument annote is equal to true. We can also pass this argument as CMap. CMap is nothing but color mapping in case if you want to change the color. Let me try some other color, maybe turbo, which is kind of a different palette. And let's execute this. This will give us the correlation value depicted on the heat map, and you can take call apart from the color. So this is very powerful way to visualize the correlation out of many things which you can do with the help of heat map. The next and the last plot we have in today's session, which is 3D scatter plot. Now this is interesting. It's more of an interactive plot which we can create with the help of Plotly library. So this plot is not there on Matplotlib and Seaborn, but we're going to import a new library called Plotly. And let's say import plotly.express as px, right? And let's execute this. Once we do that, we're going to see 3D scatter plot between three different variables. So that's the power of a 3D scatter plot. You can study three different variables in a 3D manner and visualize more effectively. This chart offers more interactivity compared to the two-dimensional plot. So let me define the object for this figure. Let's say it's figure 3D, and we're going to create using Plotly. So px dot scatter 3D plot, and here in this plot my data is df, my x column is, let's say, gender, my y column is, let's say, car age, and my z column is, let's say, home value, right? And I also wanted to encode color based on car age, right? And as we execute this cell, it has created figure 3D, and we can call this fig underscore 3D object and display it with the help of figure 3D dot show. Okay, as we do that, it has created 3D plot for us. We can zoom it with the help of scroll of mouse, or we can zoom out again with the scroll of mouse, or the options which is available on top of your chart. You can save it as a PNG, you can zoom in, zoom out, and there are a host of options which you can utilize it. There are car age color encoding which is available. So the yellow color shows the higher car age, and the blue color shows the lower car age. And this way you can see there are two different genders, so male and female, on this 3D plot. And for each of the gender, you can study the population distribution between home value and car age. As you scroll on the chart, you can also see the details of each of the point available. So you can study the particular point, like the one outlier point which you see here, which pertains to gender male and having car age of 9 years, and home value is as high as 885,000. And by this way, you can have some kind of interactivity within Python notebook with the help of Plotly. Plotly also offers so many hosts of other options which you can explore. I'm just keeping it to the 3D scatter plot to give you kind of exposure that this kind of plot also available, apart from so many host of other libraries which Python have to create more fancy visualization. So please do try and create all this visualization at your end. I'm going to post the link in the description to download this Jupyter notebook along with the data file for you to practice. And I'll see you in my next video. Please like, share, and subscribe my channel. Thanks for watching. Bye-bye.